What's the place of educational neuroscience in teacher education? In England, the early professional development of teachers is framed first by the core content framework for initial teacher education, and then by the early career framework. The former focuses on memory in this context, and the latter on cognitive load theory. It is, I think, a great advance that teachers now receive better support in their education and early careers. Certainly a lot better than I got in 1978. But both curricula present a very partial view of how children learn. This conference seeks to expand teachers' understanding of education and neuroscience and researchers' understandings of the early careers framework, and how maybe with better teacher education on education and neuroscience and its potential, we could have a significant impact on learning.
And so ultimately, what we need are good supports and modifications that make education accessible. How much variability should I expect to encounter in class? Where does this variability likely come from? And what does it mean for education?
So here's a vision that there is a continuous dialogue between educators and researchers. Now, Learnus' mission emphasizes the translation aspect from research into educational practice. Classroom challenges and policy priorities should equally update research agendas. What we really want in education is a sense of progress. Doesn't have to be fast, but an accumulation of we want to be getting better, getting answers, gradually improving practice. Ideally, when we're looking at translation of innovation, of trying to take new research findings and see how they might work in the classroom, that innovation happens through discussion, through dialogue, through co-creation.
It's always fun to come and meet with teachers and school leaders, not just to share with them about the kind of research that we're doing, but really to hear from them about their practical experience of what it's like being a teacher on the ground, dealing with the various kind of constraints that they have, the various things that they have to achieve in the classroom, and thinking about when neuroscience fits in with all of that.
It was important to me because I think we have to bring in policymakers into the conversation, and that's what I was hearing you talking about. And really nothing's going to move forward unless we have that communication and we get them convinced that this is something that needs to take a priority. There's so many pressures on education and on educational thinking, but really a scientific understanding of learning has to be a primary concern, I think.
There are still thousands of young people leaving the education system without any qualifications at all. There is an overwhelming evidence the education system leaves too many poorer students behind. The disadvantage gap is not closing.
After all, while little has been done to change it, many of us had recognised for a long time that the industrial model of education is wholly inappropriate. It makes no sense that research that could make the matter of learning easier for pupils is not even known about by teachers. And it equally makes little sense that researchers don't involve teachers in determining which aspects of classroom practice should be studied.
The frustration that I continually face is that we don't have effective translation between research and practice, between the scientists and the teachers, between the thinkers and the doers. We have world-class researchers in the learning sciences, a world-class evaluation organization in the Education Endowment Foundation, and world-class teachers. Yet the translation of the science of learning into the classroom is piecemeal and sporadic. So we do have successes, but we don't have systematic success.
Almost 30 years ago, it was assumed by neuroscientists that the human brain stops developing in childhood. We now know that that's completely false, and we know that because we now have the technology to look inside the living human brain and to track how the brain changes across age. And what that research has shown is that adolescence is a period of very substantial development, both in terms of the brain and in terms of cognition and behaviour, particularly social behaviour, and that's what we're really interested in.
The purpose of ABCD, obviously, is to learn a little bit more, understand a little bit more about attention.
And in its role in the context of learning. And that means working in the lab to understand mechanisms, but then taking the lab out of the lab. So that's one of the things that I'm really passionate about, is to also learn from teachers and learn by observing them, and learn from children in their classroom about how they learn and how they attend. So we do, about half of our work is in the lab, and you saw the pirates.
The pirates, yeah.
The pirates, very important.
Very good.
But then
chests.
treasure chests and so on. And then half of what we do is in preschools and primary schools, either locally or further away. Some of the work involves working with colleagues in the Global South to look at more diverse environments. But the key focus is understanding attention and learning and how they work together.
So my day job is a teacher, and I look after a sixth form like you guys, and I teach biology and geography and a bit of politics. But in the evenings, I have a very serious interest, I suppose, in neuroscience and the brain. Right, I'm going to talk about synaptic pruning. I'm going to talk about plasticity. I am Jeremy Dudman-Jones, and I'm an assistant head teacher at Greenford High School in Ealing. I have an interest in neuroscience and brain stuff in particular, and I've just been giving a presentation of about an hour to students from Ruislip, and there are about 200 of them. They all seem to be very interested, so I was pleased with the turnout, very impressive.
I didn't really understand how physical learning was in the brain. And especially when you sleep, I didn't know that you could forget memories.
So I will be speaking tonight about the content of my recent book, How We Learn, which I wrote to convey the massive advances that we've made in neuroscience. I mean really the world's researchers, in understanding this extraordinary ability of the human brain to change with learning. And so you were kind enough to mention that I am the director of this place in south of Paris, Neurospin, which is entirely dedicated to brain imaging, viewing the human brain. And in particular, Neurospin is quite special for its ability to image the child's brain. We've developed all sorts of techniques so that we can see little babies in MRI, in MEG, and also school-age children. And I will capitalize on this work to tell you tonight about, first, brain plasticity. How does the brain change with learning? How should we think about the problem of nature and nurture? And I will show you that they are completely combined and should not be opposed. And I will develop the example of the acquisition of reading as an example of cortical recycling, the recycling of existing circuits given by nature, and we nurture them in order to acquire reading. And in the second part of my talk, I will be talking about the principles of learning, what I call the 4 pillars of learning, and how we could exploit them for better learning. So we all have to learn how to better learn.
I think at the heart of educational neuroscience is a focus on understanding the nature, scope, and an impact of differences between individuals and how they can impact on the way that they learn. And that seems to me to be crucial for good educational practice. And so for me, the exciting thing about educational neuroscience is as we understand more about why and the ways in which some young people find learning more difficult, that can be translated into better support that they might receive in class. So getting more involved in translating scientific findings into practice and into teacher training, those are the areas I think are probably the most exciting for me in terms of where educational neuroscience could go.